So that means solve 43. If a polynomial over the real number has a complex number like 2 plus I and minus I as roots, then f of x could be. Okay. So remember that if f belongs to the real coefficient of x, if f has a plus bi roots, so this a, b are a real number, then f must has a minus bi roots. This is an important fact. Basically, because all the irreducible polynomial in R must be degree 2 or degree 1. Okay, so once you know this fact, then you can simply solve it, because so x contains 2 plus I, then x must contains 2 minus I as its roots. So two of these will give you a irreducible polynomial of x combined as this one. This one. And the second, x equals to 1 minus I, x equals to 1 plus I. This tells you that x squared plus minus 2 plus 2x plus 1 equals to minus 1. So the second irreducible polynomial is this one. So f, the simplest polynomial of x is sum L of x times x squared plus 2x plus minus 2x plus 2 and x squared minus 4x plus 5. And then we see so at least it has degree 4, and the sum of coefficient should be negative, and so a should be 1, because all the answer here has leading coefficient 1. So this is the f. So we just expanded this. Okay, so we can expand it. But I guess you don't have to expand it, that you already know the answer is e, right? Because the constant coefficient is 10. So the only remaining is b and e. Then you just check the second coefficient. Then you know the answer should be e. Okay, so the answer is e. 44. 44 asks you about this limit. You have multiple ways to solve this, right? The first way is you use a Taylor expansion, that f of x0 plus h is f of x plus h f prime of x0, and keep doing the h squared term, so a o h squared term. So this term can be this function can be written as some o h squared term plus, this is big O, plus minus fx0 minus h. So this h go to minus h, because this is x0 as x naught minus h. So f prime x naught and some leading coefficient h squared divided by h. So you get this term cancel, then you get 2 f prime of x naught times some oh term. So this term goes to 0 as h go to 0. So the answer is a. The answer is a. And another way you can solve it is basically you divide 2h and the times 2, and the limit h go to 0. And then you can relabel you can see this term basically is f prime of x naught. Because you can let this to be y, and then this is y times 2h, y plus 2h. So this is basically f prime of y naught, but y naught is x naught minus h. So when h equals to 0, f prime of y naught basically is f prime of x naught. So this tell you the answer is f prime of x naught times 2. Okay, so the answer is B. The answer is B.